So for today's science lesson, we are going to do an investigation about good insulators of heat. If you imagine you have a flask and you've got a cold drink in your flask and you're going on a 2-hour hike, it's a really hot day and you want to keep your drink cold, then the flask is a really good way of keeping your drink cold. But what we're going to do today is investigate why that flask keeps your drink cold. Interestingly, with a flask, if you put something hot in it as well, like a cup of coffee, then it also keeps your coffee hot for a very long time as well. So there's some video clips for you to watch about insulators and conductors of heat. But hopefully the investigation that we can do today will help us better understand why some materials are better at insulating than other materials. So what you need today is 2 containers. Now I've got some Tupperware containers here and they're very similar, but you can use a mug, a plastic cup, anything really, a bowl, anything that you can wrap a material around. I've got some lids for these ones because I think that will make it easier to wrap the material around as well. You will need some material that you want to test, so I've got some bubble wrap, I've got some kitchen towel, you might try tissue paper, aluminium foil, a scarf, anything that you think is quite interesting to see if that material would make a good insulator or not. So you might have just 2 pots running here, you might have 3 pots, you might have 5, 6, 7, 8 if you want to. In my 3rd container here, this is going to be what we call the control container. So that's going to have no material around. It's just going to have the ice in so that we can compare. So you also need some ice. I've got some ice cubes here. Might be interesting. You might have a block of ice. You might have different shapes, different sizes of ice, which again just to make it really interesting. The only thing that I would recommend is to have them the same size, because if you have one block of ice in this container, but then small little ice cubes in this one, it's not going to be a fair test. So we've got to keep those ice cubes the same. So in my control container, I'm going to put 2 ice cubes in there, and I'm going to put a lid on, and that will be my control one. So I'll put that alongside the others wherever I decide to place my experiment. It's important to put those ice cubes in at the same time so that again it's a fair test. Now on my other containers I'm going to prepare them with a bit of a material. So my ice cubes would be in there. I would put a lid on, and then I'm going to wrap it up in my first insulating material. So I've gone with the bubble wrap here. So I'm just going to wrap that bubble wrap around the container. The reason I decided to put a lid on the container is so that I could get the insulating material around the top and the bottom as well. And then just a bit of sellotape just to hold it in place. So that is now insulated all the way around the container, and I put it to the side. And then I would do the same with my 3rd container, ice cubes in, lid on, and wrap my material around. So in this case my kitchen roll, and then a bit of sellotape. The reason I'm using a bit of sellotape is just to keep it in place. There. So I've got my control container, I've got the container with the bubble wrap in, and then I've got the kitchen roll container as well. Now the important thing is I'm going to put them in exactly the same place. If I put this one on a radiator and this one on a windowsill and this one in the fridge, then I won't be able to test which one is the best insulator. So they all need to go in the same place, so it's the same temperature that's affecting those ice cubes that are sat inside there. Then after about 10 minutes, so I need a stopwatch or to watch the clock, after about 10 minutes I would find my sellotape, just carefully undo the sellotape and then open it back up and I would take a look at inside the container with all three open, and I'll look for signs of what is happening in there. So there's a bit of water, a little bit of melting, they're still quite a good size, and I compare it to what's happening in the other containers. Now if that ice is less melted in one container than the other containers, then that means the insulator is doing the job. It's keeping the warm out or keeping the cold in. If the ice cubes are completely melted, then that means that the material I've used on that container is not a good insulator. So what will be interesting is to see what materials you could use and what you can find out about those materials. The really important thing is when you've found out what you think you found out about the materials, is then to think about, well, why? Why is one material a better insulator than the other materials? What is it about that material that keeps the cold in and protects it from the heat energy on the outside from transferring in? Try and relate it to real life. Where do we use insulators in real life? Where do we try and wrap things up to keep them warm? Or where do we try and wrap things up to keep them cold and keep the warm from coming inside it? Make sure you post a picture or take a video of your findings or your experiment. It'd be really interesting to see the variety of things going on. If it is snowing, then you could do this with snow instead of ice. And see if you can do it outside maybe would be a really good idea. So enjoy your investigation and let us know what you find out.